Hello, Financial Lit. This is where we stopped in the last video. So we are on page, let's see, we are on page 62. We're on page 62. Okay, so we got T equals 9.307 years. So what we can do is we can actually take that number that we found and we can plug it back into the original problem and see if it works. So if we take our compound interest formula and we plug in everything we know, we want to get close to $20,000. So if we plug in the number we found 3.307. Again, this is 12 times, and we end up with 20,003 cents. That is really close to 20 grand, so that number does work. Okay, so now we've got Rudy deposited $500 into an account with 1.2% interest compounded quarterly. How long will it take for that amount to double? So again, we're going to use the compound interest formula. We've got 2 times 500. We can either put 1,000 or 2 times 500. 500 is our original principal. Our interest rate is 0.012. We don't know what our time is, but we have our N is quarterly, so that means 4 times a year. It's compounded 4 times a year. So we plug in everything that we know and we start solving. So we figured out what's inside that parentheses. We need to divide both sides by 500. And so we end up with 2 is equal to 1.003 to the 4t. And then we will get, now we are down to, back once. So now we have a number is equal to some number raised to some unknown power. So a number raised to some unknown power. So now we can take the log of both sides and apply the power rule. I just combined it, but I applied the power rule. And then I'm going to divide both sides by this 4 and this log 1.003. And I end up with log 2, and we plug that in, and we end up with about 57.85 years. All right, so that is how you would solve it with compound interest. Now let's think of something when we do continuously compounded. So when we have continuously compounded, let's turn this off. So we get Sherry deposited $8,000 into an account that compounds continuously at a rate of 3.7%. How long will it take for his money to grow to 10,000? So we can take all the things that we know. We know that we're going to be using the continuously compounded formula, which is B equals P to the E to the RT. So we're going to plug in the things we know. We know we're going to end at 10,000 and we started at 8,000, and we have all of this. So now we need to get everything by itself. So we have E, which is a number raised to some unknown power. So we need to get that 8,000 away from it. So we're going to divide both sides by 8,000. And we get 1.25 is equal to E to this. So whenever we see E, we should think natural log, because log base E is it goes with E. So log base E, natural log. So we're going to take the natural log. To wipe out E, we take the natural log of both sides. After we take the natural log of both sides, we can apply the power rule. And so we get the natural log of 1.25 is equal to 0.037t times the natural log of E. Well, the natural log of E is just 1. And so if we remember that the natural log of E, this says 0.037t times 1. So then now that's a much easier problem to solve. So now we can divide both sides by just the 0.037. And we end up with the natural log of 1.25 is divided by 0.037. You type that in your calculator, and you get T is equal to 6.031 years. All right, go ahead and hit pause, get all of that in your notes, and we'll move on. All right, I would like you to try this one on your own. Go ahead and hit pause. Okay, so hopefully you got that one correct. We were figuring out how long this one would take to double. This one was very similar to the one we just did, and you should have gotten 24.84 years. If you didn't, here are all the notes. Go ahead and get this in your packet. Go ahead and hit pause, and you try this one. Okay, and again, I set it all up for you. We're using the compound interest formula on this one, not continuously compounding. And so we will plug all of the things in. Hopefully your math matches up with mine, and you got 6.04 years. Okay, so you have some homework to get done. If you go to page 64, at the bottom of 64, You should be able to do all of that. You're going to go all the way to page 66 and then you can stop. And you guys will be ready for the formative on Monday. And then you will all we'll do some practice together and then you will be able to take the test on Thursday. So I hope you all have a great day. I will see you all next week.